Nuclear Notes, page 229. So we have this term transmutation. You should be familiar with the term mutation, especially from living environment, and it entails the idea of change. And when we put trans in front of it, trans in this case would represent the idea of species. So a transmutation is a change in the species. Nuclear reactions are considered a change in the species because we start with one element and end with a different element. So the change of the nucleus of one element into the nucleus of a different element. In a nuclear transmutation, the element always decays into a more stable element. Now, transmutations, nuclear reactions can be subclassified into two major categories. One category is referred to being natural, the other one is referred to as artificial. So natural transmutation versus artificial transmutation. So natural transmutations happen with unstable atoms. And just a quick note, remember, if the element's atomic number is 83, all atoms of that element are unstable. So take a look here. Here's a quick example. So notice I have the starting of a natural transmutation and the reactant side of an artificial. So one way you can look at a nuclear reaction and recognize, hey, this is a natural transmutation, is that natural transmutations, we will only see one reactant, versus the artificial, we'll see two reactants. Okay, so here we go. Let's just fill this in so you can see example of how a natural transmutation reaction occurs. So uranium-238, it's unstable. So this is naturally unstable, and its nucleus falls apart. And when its nucleus falls apart, I like to say it spits out He4 with a mass of 4 and an atomic number of 2. And this is the bad stuff. This is its decay mode that you can find on table O. So this is the particle that is sent out of the unstable nucleus that if you're overexposed to, that can cause all the sickness. Then we have to figure out what remains. So the original has a mass of 238. It spits out a particle, a bad particle with a mass of 4. So the new nucleus, which is more stable, has the remaining mass. So the remaining mass is 234. Now, the unstable nucleus has 92 protons, but when it spits out the bad particle takes 2 of the protons with it. So the new, more stable nucleus has 90 protons. And remember, if you change the number of protons, you change the identity of the structure. So a nucleus with 90 protons is no longer referred to as uranium, but if you look on your PT, you'll see that it belongs to an element with a symbol of TH that we call thorium. So the natural transmutations that you will need to be able to write the decay reaction of include the following. You have to be able to do the alpha particle decay. You'll need to be able to write out the beta particle decay. Should have the word decay in here. And then you will also have to be able to write out the transmutations that involve the positron, but instead of referring to it as a decay, they refer to it as an emission. And emission just means to give off.